We're going to continue to solving inequalities. So we should be good at solving logarithmic equations. All you got to do is know how to get rid of logs by raising both sides of the equation to become powers of the base on your logarithm. That way you could cancel out and you could solve. But what if it's an inequality? Well, you do the same thing. You solve the way you always would, but there's also an additional step to it. So on example 3 in the book, how would we get rid of that log base 3? You would do base 3 here, base 3 there. That way, this is a power of base 3, which cancels out. And then the x will come down. So the x comes down, and I'll just jump to the work right here shown. X comes down, and 3 to the 4th is right there. And of course, the inequality is right there. So you have x is greater than 3 to the 4th. And your final answer, 3 to the 4th, is 81. So x is greater than 81. So I hope that makes sense. What we need to do is also assure ourselves of an extra detail. The inside of the logarithm has to be greater than 0. So it's a good idea to state that the inside of the logarithm, and in this case, the inside of the logarithm really is just x. So x has to be greater than 0, right? That's a detail, a requisite that we need to have. Now, we also have the answer, x is greater than 81. Now, the book doesn't explain this, but I want to show you that the best thing to do here would be to make a number line and draw those inequalities on a number line. So if x is greater than 81, let's say 81's over here, greater than is that way, okay? And if you think about x is greater than 0, 0 is right here, and greater than 0 is that way. So when you think what your answer is going to be, you have to represent your answer with the overlap piece. And the overlap is at greater than 81. So your answer really is x is greater than 81. Now, if for some reason this would have been x is less than 81, then the 81 would be less than, which would be going this way, and the 0 is greater than, so it would be an overlap piece in the middle, and you would have to write that as a compound inequality. Okay, you'd have to write that as a compound inequality. Let me show you what I'm talking about. Let's take a look at this example down here. Log base 4 of x is greater than or equal to 3. Okay, so in this case, what would I do to solve it? Base 4 here, base 4 there. That cancels out. X is greater than or equal to what?
4 to the third.
Yeah, and what is 4 to the third? 64, right? 4 times 4 is 16. 16 times 4 is 64. So x is greater than or equal to 64. That's an answer. However, we know that also this x value has to be greater than 0, because if it's 0, you wouldn't be able to do log base 4 is 0. It has to be positive, so it has to be greater than 0. So I'm going to actually take the inside of the log base 4, the x, and I'm going to set it greater than 0 because it has to be greater than 0. So technically, both of these guys are part of my answer. Now, the best way to go about this is to do a number line and see if there's an overlap. So 64 is over here, 0 is over here, x is greater than or equal to 64, that is greater than, to the right. And x is greater than 0, that's also to the right. Where's the overlap piece? It's right here, which means that x is greater than 64, so this is the only answer that you have. It's not a compound inequality. But sometimes it might be a compound inequality. So it's always a great idea to do this number line. Let's try this one right here. How would I solve this one? Base 2 on both sides, cancels out, x comes down, less than comes down, 2 to the 4th is what? 2 times 2, 4 times 8, that's 16. 16, right? Okay, so we have x is less than 16. Now, let's also go back, and this second part is essential. We've solved it, we got an answer, but you need to go back and look at the inside of your log base 2. It's of x. This x has to be greater than 0. it has to be greater than 0. So I need to write that. My x value, the inside of the logarithm, has to be greater than 0. So let's think about this on a number line. On a number line, here's 0. X is greater than 0 is to the right, and x is less than 16 is to the left, right? So where's the overlap piece? The overlap piece is right here in between. So in this case, your answer is not x is less than 16 or x is greater than 0, but both written as a compound inequality. And that compound inequality is going to be the x in the middle, the smaller number on the left, the bigger number on the right, 16, with less than symbols right there. So this is your compound inequality answer. 0 is less than x, which is less than 16. So it's very essential that you think about the number line and represent your overlap piece. Okay? Now, if they're both in the same direction, then the overlap would be over here, x is greater than 16. Or let's say they're both in this direction, then the overlap would be over here, x is less than 0. But they're pointing towards each other, so the overlap piece is between 0 and 16, so you write it as a compound inequality. So with that said, we need to understand these steps right here on solving inequalities. Solving equations is easy. You want to get rid of a log, raise both sides to be the power of the base that was on the log. But these are the steps to solving inequalities. Step 1, solve and get your answer the way you always would. Step 2, set the inside of the logs, because you might have more than one log, set the inside of the logs to be greater than 0 and solve. Step 3 is to graph your inequality answers on a number line, and the overlap area is your answer. You may have to write this as a compound inequality. It might be a compound inequality, it might not be a compound inequality. So these are the steps to solving logarithmic inequalities. So let's take a look at example 4 in the book. And example 4 has log base 4 of the binomial x plus 3 is greater than log base 4 of the binomial 2x plus 1. So ladies and gentlemen, let's solve. Step 1 right here says solve and get answer. That's step 1. Just solve it. All right? So let's just solve this thing. How would I start solving this thing to get rid of the log base 4? Raise both sides to be powers of base 4, right? And the inequality is now between the 4s. Of course, that cancels out. This cancels out. Your new equation is this guy that they rewrote down here. Okay? You have the x plus 3. You have the 2x plus 1. You have the greater than symbol. Now let's solve this. Well, if you subtract x and move it over, you have 1x. If you subtract 1, move it over, you're going to have 2. So you really have x is less than 2. X is less than 2. So this is an answer. That was step 1. That was step 1 over there. Solve and get an answer. Okay, we did step 1. Step 2, set the inside of the logs to be greater than 0. Right? So let's go back to the original. Now we know that this has to be greater than 0. It can't even be 0. It has to be greater than 0. So I need to go back and actually set x plus 3 to be greater than 0. So let me do that right here. X plus 3 has to be greater than 0. Now if I solve this thing, my answer will be x has to be greater than negative 3. And I want to keep that in mind. That's a restriction to my answer. X has to be greater than negative 3. Not only that, I'm also going to go to this other logarithm. This other logarithm, the inside of it has to be greater than 0. So I'm going to end up with 2x plus 1 has to be greater than 0. And when I solve it, take away 1 on both sides, that cancels. You're going to have 2x is greater than negative 1. When you divide by 2 and divide by 2, you're going to get x is greater than negative half. So x is greater than negative 1/2. Okay, so we really have, in a sense, 3 answers, 3 inequalities. Now, the way to find out what the true answer is to think about the number line and find the overlap piece to all 3 of them. Okay? So, I'll do this on the side. Number line. Let's go with this first one right here. X is greater than negative 3. Okay, well, negative 3 is right here. And greater than is to the right. Okay, and then let's go for this next one. X is greater than negative half. Okay, well, negative half is closer to the positives, but greater than still to the right. Let me do a different color here for negative half. So that way also. And the last one, the actual answer that we got, x is less than 2. Well, here's 2. Less than 2 is this way, right? So where is the triple overlap piece? Where's the triple overlap piece? The triple overlap piece, this red one keeps going this way, keeps going this way, keeps going this way, right? The black one is going that way, and the blue one is going this way. Where do you have the area that has both the black, the red, and the blue line? This right here, this area right here. It has nothing to do with the negative 3. Does that make sense? Yeah. So let me change colors here and show you that here is the triple overlap piece between the negative half and the positive 2. So the answer to this guy is to rewriting it as a compound inequality answer, which is pretty easy to do. You simply put x in the middle, the smaller number on this side, the bigger number on that side, with the inequalities right there. So here's your compound inequality answer. But the only way to get this answer is to follow the steps that I provided before to you. And those steps are right here. Solve, get an answer, and then set the inside of the logs to be greater than 0 and solve. And then take all of your inequalities, put them on a number line. The overlap is your answer. So if there's 3 inequalities, you got to find that triple overlap. If there's 2 inequalities, just the 2 pieces, the 2 lines that overlap. If for some reason they don't overlap, then there would be no solution. So if we go to the book solution, I mean, they have their reasoning, but there's the answer right there. The compound inequality that we got, but they did it all without doing a number line. They just thought it through. I think it's easier to understand if you do the number line. You want to represent the triple overlap piece. If there's 3 inequalities that you're dealing with. How about this? We're going to end this video right here because there's not much time left. And we're going to start on our homework on the next video.